So we have been talking about how we can use the chain rule and implicit differentiation, but let's try solving a few problems using implicit differentiation. So x plus tan of xy equals 0. Let's say you wanted to figure out dy over dx. You're going to figure out how fluctuations in x change y. And this problem literally screaming at you to use the implicit differentiation technique. So let's just differentiate both these sides. So d over dx of x plus d over dx of tan of xy is equal to d over dx of 0. Well, this thing's just equal to 0. We do know that. And we also know that dx over dx is equal to 1. The derivative of x with respect to x is equal to 1. 1 plus, and we need to do this, d over dx of tan of x times y. So herein you need to apply a different strategy. This right here is a product, but that's inside tan, so you can see there is a chain rule right here. So let's use the substitution that w is equal to xy. So what that means is now this problem actually becomes d over dx of tan of w is equal to 0. Now, again, you need to apply the chain rule here. So 1 plus, now instead of d over dx, you need to replace this by d over dw of tan of w, not tan, it's tan. And that being multiplied by dw over dx, this just gives you a nice enough expression for the chain rule, is equal to 0. Now we do know that this part right here, this is just simply sec squared w, so let me just write that sec squared w. We still have not found dw over dx, so w is equal to x times y, and what that means is that dw over dx is equal to d over dx of x times y. So this is just a product of two functions, x and y. Y is a function in its own right, but let's skip that for now. So let's say we multiplied x times the derivative of y, so x times dy over dx, plus y times dx over dx. That's just the product rule. And let's take all of this, plug it here. So we will get 1 plus sec squared w, we already have got that, times dw over dx actually becomes x times dy over dx plus y times dx over dx is just 1, so let's not write that, is equal to 0. Finally, let's just see whether we have any alien terms, and yes, there are. Instead of w, you need to write xy, so 1 plus sec squared of xy times x times dy over dx plus y is equal to 0. We can do some more algebraic manipulations. So you can write x times dy over dx plus y, this entire thing in bracket, is equal to negative 1 over sec squared of x times y, or negative cos squared of x times y. And again, a bit of more algebraic manipulation will land you at negative cos squared xy minus y, all of this being divided by x. This is the derivative of y with respect to x when you have this sort of an implicit definition. Let's move forward. Let's say you wanted to figure out, let's take d squared y over dx squared here. Now, again, this is a type of equation where you would think that, well, we can try to manipulate some stuff and then apply calculus, but really implicit differentiation for me is the better way here. So we first need, in order to find the second order derivative, let's first find the first order derivative. So d over dx of 2x cubed minus d over dx of 3y squared is equal to d over dx of 7. And now we also know that, well, the 7 is just a constant, so that's going to be equal to 0. The derivative of 7 is going to be equal to 0. We also know that this thing right here, that's pretty known to us, This is just 2 times, since 2 is just a constant, times the derivative of x cubed with respect to x. So that is 3x squared minus, now here you have first 3, so let's write that away. 3 times d over dx of y squared is equal to 0. D over dx of y squared, well, that's another term, so you can write d over dx of y squared using the chain rule as d over dy of y squared times dy over dx. And this entire thing is just 2y, since that's the power rule, multiplied by dy over dx. And all of this comes right here. You have 6x squared minus 3 times this entire thing. So 6y dy over dx is equal to 0. This just gives you the fact that dy over dx, well, that's just algebra, is equal to x squared over y. That's pretty good. Now, let's try using this and finding out dy over dx. Now, instead of using the quotient rule this time, I'm just going to continue manipulating and differentiating on this definition that we have right here. So what I do is I write d over dx. I'm redifferentiating whatever we have got after differentiation, so that's pretty nice. This would be d over dx of 6y times dy over dx. All of this is equal to 0, since you can do d over dx of 0, but that's just equal to 0 anyway. This entire thing right here is equal to 6 times the derivative of x squared, and that is 2x, minus this thing is a product of two functions. dy over dx is a product, is a function, and 6y is also a function. And what we do right now is that we say, okay, let's apply the product rule. So we have a 6 here, so let's just write that out. So we have 6 times d over dx of y times dy over dx. This is what we have got. All of this is equal to 0. So we now have d over dx of y dy dx. This is just a product. So we will first differentiate y. So d over dx of y, let me do this in blue and let me do this in white just to avoid any ambiguity. And d over dx of y, I usually miss out on that one. And we multiply it by the function, the other function is dy over dx. Plus, we now differentiate the second function. So d over dx of dy over dx times the first function that we have, so y. If you want to figure this out, it's really easy now. This thing is just dy over dx. This is also dy over dx. So what is this? This is actually the square of the first order derivative. And this thing right here, the derivative of the derivative, that's the second order derivative. I'm doing all of that in the margins, but just pardon me for that. All of this is being multiplied by y. I mean, the second term is being multiplied by y. Put all of this in. Put all of this here right in. So this would be, in fact, we can also cancel out the 6's. I didn't observe that. So now we have 2x minus, in the brackets, we have this entire thing. So dy over dx squared plus d squared y over dx squared times y is equal to 0. Now here, when we needed to figure out d squared y over dx, and there is this other thing, the first order derivative, but we already know about that. That's x squared over y. So 2x minus x squared over y squared plus y times d squared y over dx squared is equal to 0. Again, a bit of algebra will yield you y times d squared y over dx squared is equal to 2x minus x to the power of 4 over y squared. Or well, that's the separate question. So I guess I overextended the things. But anyways, This just gives you, again with some algebra, this just gives you 2x over y minus x to the power of 4 over y cubed. So I hope that this has given you some exposure to the implicit differentiation technique that just is sort of a byproduct of the chain rule. Let's think of one more example before I end this video. And this is a particularly easy example if I wanted to, let's say, figure out the derivative dy over dx. You would say, well, this is just a product. This is a composite function. This is a product. You could have done all sorts of things, you know. But what if I said, well, I don't want to figure out dy over dx. I want to figure out dx over dy. And you would say, why? And I would say, okay, I want to figure that out because I want to know what changes happen in x if I tweak y. And that would be interesting. So instead of differentiating with respect to x, we now are differentiating with respect to y. So d over dy of x squared times cos of 1 over e to the power of x times cos of 1 over e to the power of x is equal to d over dy of y. And now that's a bit interesting. This entire thing is just equal to 1. We know that dy over dy is equal to 1. That's obvious. This right here is a product of two functions. This is one function and this is one. Also, just to reduce writing 1 over a lot of times, let's just write e to the power of negative x, because that saves some time. And now we just need to apply the product rule here. So this would be d over dy of x squared times cos of e to the power of minus x. And then plus, now you differentiate the other one, keeping the first one the same. So x squared times d over dy of cos of e to the power of negative x is equal to 1. Now, this is particularly a bit of a long problem. So let's break it down into simpler ones. So dx squared over dy. Well, how do you figure that out? Again, that's chain rule. That's just sort of the technique that we used in implicit differentiation before. It's just the same. You can write this as d over dx of x squared times dx over dy. And similarly, right here, you have the same sort of situation. You can write this as d over dx of cos of e to the power of negative x times dx over dy. All of the things are known, by the way. And we also know what this is equal to. This is equal to 2x. So this is 2x times dx over dy. The only thing that we don't know yet is this. So let's figure that out, and this problem will be out of our way. So we have to differentiate cos of e to the power of negative x. This right here, you can see it's a chain rule. It says that you have to apply chain rule. It's a composite function. E to the power of negative x is inside cos. So what that means is that you can say, okay, let's take this to be something, let's take this to be u. And we're really invoking a lot of variables, but anyways, this would be d over du of cos of u times du over dx, just the usual chain rule stuff. This right here, the derivative of cos is equal to negative sine, we know that. Negative sine u times du over dx. So we need to differentiate e to the power of negative x with respect to x. This is again chain rule, but you might have done this enough times. You already know this is equal to e to the power of negative x. This, if you do the math again, these negatives will subtract. Instead of u, you would write e to the power of negative x, and you would get e to the power of negative x times sine of e to the power of negative x. Put everything right here. This is a long problem, by the way. Let's just take everything downwards. So we had 2x times dx over dy times cos of e to the power of negative x, cos of e to the power of negative x. And then after that you have plus x squared times this entire derivative you have here. So e to the power of negative x times sine of e to the power of negative x times what you got till here, times dx over dy, times dx over dy. This is equal to 1. And finally, we can take dx over dy common out, and you can just divide everything on the other side, take everything on the other side, and this will give you 2x times cos of e to the power of negative x plus x squared times e to the power of negative x times sine of e to the power of negative x. All of this is the derivative of the function. This was a longer problem. See if you can, again, try and solve problems like these. See you in the next videos.